Okay, so today we're going to be talking about patterns and relationships in tables. And so we've already looked at creating an expression when it comes to a output or input numbers. And so then today we're going to look at finishing a table that's already been started or starting one from an expression. Okay, so if you take a look at page 15, we're looking at these two tables, and this one's different on the top. So we're going to find the relation given the table of values. So often we're given the expression and then creating a table. We're doing the opposite today. We're going to be given a table.
Hello?
Hello?
Hi, can you tell me if Melanie's there?
Yep.
Thank you.
Okay. And so we're going to be given a table and then finishing the table and then creating the expression that goes with it. Okay? So finishing a table is easy when you look at the pattern in the table. You don't even have to think about the expression quite yet. So you look at the pattern in the table. Here we're looking at each input is going up by 1. So if this was not completed, we're looking at the table that's in your notes. So if you can't see where I'm standing, then just look at the table that's on the bottom of page 14. Okay? So the input is going up by 1 and the output is going up by 4. So you're looking for patterns in the output and the input, and sometimes they're going to be similar and sometimes they're going to be different. This one's different. This one's going up by 1, 1, 2, 3, 4, 5. That isn't always the case, although most of these are. And then the output is going up by 4. So easy to complete the table once you figure out the pattern. So if the bottom two numbers were missing, you would just count by 4s and finish up the table. Okay? So finishing a table is really about looking for the patterns. Sometimes it's going to be addition, sometimes it's going to be multiplication, sometimes it's going to be subtraction, and sometimes it'll be a combination of two of them, and we'll talk about that in a minute. Okay? So we don't need to look. I'm going to turn off the screen, and then we're going to look at the rest of this page. Okay. All right, so turn the page to page 15. The first part, we're just evaluating the expression, but I actually want to look at some of the examples, and so I'm going to write one on the board, and we're going to try it together. So we're going to complete the table for B. Okay, so take a look at B. It has a table that looks like this. And my input is 1, 2, 3, 4, 5. And then we want to look at the output, and it says that the expression is 3n plus 1. Okay, so you're just looking to plug in n like we did in the first lesson, so that you're completing your table of values. Okay, so the first one, what is my output going to be if it's 1? What's my output going to be? 4, yeah, because you're basically throwing 1 into where the n is. And you're doing it, now this is already in the order of your order of operations, so you just have to go left to right. Pretty easy. 3 times 1 plus 1, so that equals 4. Okay, so the rest of the table, what would be, if this was 2? What's that going to be? 7, yeah, so because 3 times 2 is 6, plus 1 is 7. Okay, are there any questions about that so far? It's what we've been doing, right? Okay. Take a look at the bottom, though. This is, we are going to explain how the output number is related to the input number. Okay, so you're basically telling me when input goes up by 1, what happens to my output? Okay, when input goes up by 1. So for A, input is going up by 1. It's increasing by 1. What is my output going up by in this chart? If I go down my chart, what is my output going up by? For the pattern. The rule is n plus 5, but it's not going up by 5. 6 to 7 to 8 to 9, right? Because if I have my chart, right, this is 2A. Okay, so my input is 1, 2, 3, 4, 5. And so my output is n plus 5. Well, what is n plus 5 for 1? 6. What's n plus 5 for 2? What's n plus 5 for 3? 8, 9, 10. So my input is going up by 1. My output is what's happening to my output. It is it is also going up by 1, even though I started at n plus 5. So you have to finish the chart. So input is up by 1. Fill this in. Output is up by 1. Okay, that's different than the expression for the chart. It's not going up by 5, is it? Is this going up by 5 each time? No, it's only going up by 1. Okay, so that's how the input number is related to the output number. Okay. All right. So I want to, so each time I want you to complete, we're going to be completing each table, and then, but we're also going to be writing relations, so I want to do 2 examples of writing relations. So put down your pencils for now, I just need you to look at the board. Okay, so I'm going to give you a couple examples how to write a relation. One's going to be pretty easy and pretty simple, 1 step, but then we have other steps. Other ones that require 2 steps. Okay, 1, 2, 3, 4, 5. Okay, so let's say I have this chart. Let's say inputs 1, 2, 3, 4, 5, but then I have 0, 1, 2, 3, 4. Okay, all right. I'm going to stand on this side, just so this side you can see. Okay, so if my input, how is my input related to my output? What's happening to my input? It's going up by 1, and my output is what's happening over there? It's going down by 1, right? So how am I going to figure out what is my rule? How did I get from 1 to 0? What did I do? I subtracted 1. How did I get from 2 to 1? Subtracted 1. How did I get from 3 to 2? Okay, are we seeing a pattern here?
Totally.
Yeah. Okay. So what is my expression, a relation for this table? What is my algebraic relation for this table? N minus 1.
I'm so smart.
Does that make sense?
Yep.
Okay.
Yes.
Now I'm going to get it a little complicated. Okay.
Oh no.
Okay. Okay, let's do
Over.
okay. So here's where it gets a little more complicated. This is a 2-step algebra, and I can check because I'm like, oh my goodness, how did I get from 2 to 4? I went up by 2. How did I get from 3 to 7? I went up by 4. How did I get from 4 to 10? Went up by 6. Okay, so it's not making a lot of sense. It's not the same each time. If it was the same each time, like this one, it's just a 1-step expression. Here it's not. Okay, do you see how they're different each time?
Yeah.
That gives me the clue that I need something a little more complicated. And I'm going to show you how to solve these. Okay, so to figure this out, I'm going to think, okay, what is my right column, my output column, right? This is the input and this is the output, right? My output column, what is it going up by each time? 3. That's a clue that it's getting multiplied by 3. Okay, that's my clue. So I'm going to put 3n. Now, okay, do you see where I got the 3 from? It went up by 3 each time. Plus 3, plus 3, plus 3, plus 3, right? Okay, now I know it's getting multiplied by 3 each time. Now, 5 times 3 is not 15. What is 5 times 3? Or sorry, not 13. What is 5 times 3?
15.
It's 15, right? It's 15. How am I going to get to 13? What do I have to do to it to make it 13?
Subtract 2.
Subtract 2. Let's try it with this one. 4 times 10 is not, or 4 times 3 is not 10. What is 4 times 3?
12.
12. How am I going to get it to 10?
Subtract 2. Wow.
3 times 7 is not, or 3 times 3 is not 7. 3 times 3 is
9.
9. How am I going to get to 7?
Subtract 2.
So this is how you're going to come up with the 2-step rules. Let's try it one more time. Okay? 1, 2, 3, 4, 5. Let's do this one. Let's do 10, 15, 20, 25, and 30. Okay. What is this output column going up by? 5. 5n. Okay? 5 times 5 is not 30. How am I going to, what is 5 times 5?
25.
25. How am I going to get it to 30?
Plus 5.
Plus 5.
Whoa.
4 times 5 is not 25. 4 times 5 is?
20.
How am I going to get to 25?
5.
There's your rules.
Now.
Okay? Does that make sense?
Yeah.
Okay, it's a little trick to find the two-step ones because they're a little difficult otherwise. So it's be more of a guess and check than otherwise. Okay? So we're going to work on page 15 and 16 to figure out our pattern rules, our input-output relations, and our algebraic expressions. Okay?